Hey, what's up guys? So today we're going to be discussing problem number 4 in the 2010 AP FRQ question. This is just going to be like a regular AP exam, and these are the questions that they might be asking. So I'm here to help out and help you guys get a better understanding for what to expect. Before I begin, once again, I'd like to give a quick shout out to Mr. Happ for having us do this project. Thank you, Mr. Happ. Alright, so let's begin. Let's begin by reading the problem. We always want to read all parts of the problem. Let R be the region in the first quadrant bounded by the graph of y equals 2 root x, the horizontal line y equals x, and the y-axis, as shown in the figure above. So it's very important to make sure that we look at this graph and look at what they're asking. We know that this line, this curve, is y equals 2 root x. So we should just draw it on there just so that we know the top line is y equals x. So question 4a, find the area of R. So basically what we do, guys, is we know how to find the area. We've been through that before, and let's just walk through that. So what we're going to try and do is we're going to try and find the area of this R section, okay guys? We're going to try and do that. So first of all, we know that it's going from 0 to 9 because this graph ends at 9. This is where these two graphs intersect at 9. So what we're going to do is we're going to draw the integral, and it's going to be from 0 to 9. Next, what do we need to do? Next, what we're trying to do is we're trying to find that area that is in between the graphs of y equals 6 and y equals 2 root x. Now, how do we do that? What we're going to do is we're going to set up this integral, and we're going to subtract the top, and it's going to be the top minus the bottom. So guys, pause this video and try and figure out what the top is and what the bottom is. Alright, once we figure that out, we know that the top is y equals 6. So what it's going to be is that we're going to do 6 minus 2 root x dx. And that's going to be our integral for this problem. And what we're going to do is that, how do we solve an integral? We need to find the antiderivative. So the antiderivative will be 6x, and then we know that this will be 4 over 3 x to the 3 over 2, because what we do is we'll make the root x to the half, add 1, and divide by that new thing in front of the x, and so it's going to be minus 4 thirds x to 3 halves, and the bounds will be still 0 to 9, and once we plug all that in, we're going to get 18. So that will be our answer for part A. That will be our answer for part A. So that's the find the area of R. So we know what we did. We subtracted the bottom from the top. So basically top minus bottom, set up that integral 0 to 9, get the antiderivatives and solve and get 18. Let's go on to part B. So part B states, write but do not evaluate an integral expression that gives the volume of the solid generated when R is rotated about the horizontal line y equals 7. So what I'm going to do here, guys, is that I'm going to take this and I'm going to draw just a dashed line and pretend that that is y equals 7. So we can see that right there. That is y equals 7. So write but do not evaluate. That's very good, because these problems, guys, we should be able to solve extremely quickly. An integral expression that gives the volume of the solid generated when R is rotated about the horizontal line y equals 7. So what do we know? We know that to find the volume, we're going to do the same thing, except we're going to have a pi in front. It's always going to be multiplied by pi, integral of 0 to 9, and it's outer radius squared minus inner radius squared. So guys, once again, pause the video to see if you guys know what the outer radius and inner radius is, and we'll be back. Alright guys, once you've paused the video and determined the outer radius and inner radius, we know that it's actually going to be 7 minus 2 root x, because the 2 root x is the outer radius. 7 minus 2 root x. 7 minus 2 root x squared, outer radius minus inner radius, which would be 7 minus 6 as we can see right there, minus 7 minus 6 squared dx. And that's it. That is all we need to do. Because it just says write, but do not evaluate an integral expression. These should be the easiest problems, guys, because we're just basically just writing an expression. We're not even solving it. Now let's go on to the last part, part C. Region R is the base of a solid. For each y where 0 is less than y less than or equal to 6, the cross-section of the solid taken perpendicular to the y-axis is a rectangle whose height is 3 times the length of its base in region R. Write, but do not evaluate an integral expression that gives the volume of the solid. So once again, key point, okay, again it's just write but do not evaluate, but key point, perpendicular to the y-axis. So that means that this is going to be going this way. It's going to be perpendicular to the y-axis as opposed to the x-axis. That's how these test makers like to confuse you guys, so always remember to read the question completely. So let's go to C. So what we're going to be doing is that first we need to determine what it is in terms of x. So when y equals 2x, solving that would get us x equals y squared over 4. X equals y squared over 4. So that's one side, but again, this is a rectangle. So a rectangle is always base times height. But we know that the height is 3 times the length of its base. So what we have to do is we're gonna have to be, because it's 3 times, so it'd be 3y squared over 4 times y squared over 4. And multiplying this, guys, would give us 3 over 16 y to the 4th. So now just writing the integral, it'd be 0 to 6, because now now we're looking at the y-axis, so 0 to 6 of 3/16 y to the 4th dy. And that, guys, will be our answer. So let's just go over the answer key and determine and see how we've done. So this is the answer key. So we can see that in problem number 1, they're giving us 3 points. 1 point for the integral, 1 point for the antiderivative, and 1 point for the answer. Let's look back at our paper. We can see that we have achieved all 3 of these points, as we have the integral, we have our antiderivative, and we have our answer. So right there we have our 3 points. Now let's go to number 2. 2 points for the integral, 1 point for the limits and constant. Let's go right back to our paper. We can see that yes, we do indeed have the integral and the limits and the constant, so we will again get our 2 points there. And the third one, 2 points for the integral and 1 point for the answer. Let's see, we have the integral and we have the answer, which is the same exact answer as the answer key. So great job today, guys. We've really learned how we can answer these FRQ problems and answer them to the fullest, and make sure to always pay attention to the question. Now, if you guys would like some extra practice with this, this will be chapter 6 in your AP Calculus textbook. All of chapter 6 will be talking about the areas between the curves, volumes, and cross sections. So you guys can go to chapter 6, chapter 6.1, chapter 6.2, chapter 6.3 to do some more problems and help practice and help be the best that you can be. All right, thank you guys for listening. And once again, I'd like you to hit that like button, comment, share, subscribe, get this video out there, make sure a lot of people can see it. Thanks, guys.